Well, good afternoon. Is Mike in the audience? I guess he's not. Anyways, I'll send my congratulations to the team that built Aquistore. Tremendous accomplishment. And although the ribbon cutting tomorrow does indeed mark a milestone, that is not the end of the journey. And PTRC is very, very pleased to act as managers for SaskPower in terms of the MMV for the Aquistore project. Just a little shot there on the PTRC. I want to emphasize that our business model talks about collaboration both from the agencies that provide funding and collaboration with the research institutions that provide the research that goes on within the PTRC group. We act as an independent researcher. We're counted on by governments, by regulators to provide that independent research, and also by industry. And although one of our main things is enhanced oil recovery, both conventional and unconventional, we do manage projects in the CO2 space, and you'll see up there the IEA GHG Weyburn-Midale project, Aquistore, and the new one, Sask CO2 User. Although these are individual projects, they're individual only by their nature of funding. PTRC began its work on storage with the Weyburn-Midale project, and you've heard a lot about that here today. Our goal there was to operate a research program in parallel with a commercial enhanced oil recovery project. And to do that, we aligned ourselves with the operator, and our role there was to provide the MMV with the ultimate goal of assurance on storage integrity. Although these are somewhat discrete projects, they do build upon each other. And each one, the gaps, leads to some conclusions, and then further study and further work by other agencies who want to participate in the research that PTRC is doing. So from the Weyburn-Midale, can the knowledge that was gained there be extended to other forms of geological containment? Well, we certainly thought it could. And the Best Practices Manual, which was the outcome of the Weyburn-Midale project, talks about what validates CO2 storage regardless of the type of geological container. But for CCUS to move forward, Aquistore and Aquistore and the CO2 user group are to fill in gaps in knowledge. Just a couple of examples. What new technologies are there for measurement, monitoring, and verification? And are they necessary? What is really necessary? In a commercial operation, you'll likely have stops and starts. What does that do to the movement of CO2? How does this affect the MMV? How do we target this? How do you transition from a CO2 EOR to pure storage? It's a question that a lot of people want some answers to. And of course, the holy grail that we want to try and find the answer to is, can we actually see it underground? Because if we're going to give a credit for it, if some agency is going to give a credit, they will want to know that it's there to satisfy those people that are asking for the credit. So Aquistore. The technical aspects of Aquistore are really directed by a science and engineering review committee. And that committee is made up of the best people that we can get our hands on in the world with regard to the topics of geology, geophysics, geomechanics, risk assessment, wellbore integrity, all those issues that affect the storage of CO2 underground. We are expecting the Aquistore project to give us some unique results that may not be yet available in other projects in the world. The reason for that is Aquistore is kind of a buffer. It sits roughly in between the carbon capture unit and the ultimate sale point that SaskPower needs for the revenue, the sale point of the CO2 to the operator at the Weyburn-Midale field. And we'll act as a buffer. We can take the CO2 when the off-taker doesn't want it, the plant goes down, or things of that nature. So we're going to see some interesting things that happen with that. And those learnings are, I would say, unique to what's happened so far in the space of CCS storage. Activity to date, well, I could just simply say the wells are drilled and we're ready to go. But I want to provide a bit more information than that, and something that is probably quite specific to Saskatchewan. We drilled 2 wells. One's an injection well, and one's an observation well. And I'll get into some more detail on those. In terms of the site characterization and selection, a lot of the issues that we did within the Aquistore were learned from Weyburn-Mydale. And Saskatchewan has the benefit, especially in that area, that there are quite a few penetrations through the various formations. And there's a very good data set. And that data set is held by the Saskatchewan government. It's all electronic. You can go on there. You can do all your cross-sections. You can figure out where the formations are and things of that nature. So we did that, and lo and behold, there's a real nice site just a mile and a half, 2 miles away from the power plant. So to further narrow that down, run some 3D seismic and find out exactly where to drill the injection wells, and then the observation well was drilled 150 meters from that. Since they've been drilled, and prior to the drilling, we've done a lot of monitoring, and I'll get into that in a minute, and a lot of baseline studies have taken place. In terms of the technical monitoring, you will note on this slide that some of the items are highlighted in blue, or I guess I could say they're highlighted in black. But the black represents what was done at Weyburn-Mydale, and the blue represents the additional things that we are doing on the Aquistore project. And you can see that in the Aquistore project, we're doing things that are more in tune with what's happening downhole. Because, of course, in Weyburn-Mydale, we were not the ones that were particularly interested in a lot of CO2 conforming, how it went in the formation, where it went. That's the operator. The operator did their things on how they're managing the CO2. We were more concerned about surface issues. Some things that have been added, I'll just talk about a couple. You can see that we're looking a lot at seismic activity. We have gravity meters, we have tilt meters, we have a permanent seismic array that's down there, vertical seismic profiles, a lot of things there, and I'll get into a bit more in that in a minute. We also have a few things with fiber optics that are going to be testing some new ideas as well. This is the second deepest well that was drilled in Saskatchewan. It's the injection well that goes down to almost 3.4 kilometers. When we were drilling the wells, what we wanted to do was to have the best well we could, because we knew we were going to stick a lot of jewelry along the casing. We actually drilled the 3.4 kilometer wells using a full invert mud the entire distance. Made for a nice clean hole all the way down, allow us to put in the instrumentation on there. This is the injection well, and I just want to point out a couple of things. But if you look at the Deadwood Formation, which is this kind of the light-colored formation at the very bottom, that's where we're going to be injecting. You can see the perforations in there. We've got some pressure gauges downhole, and one of the pressure gauges is going to measure above the seal, which is the icebox shale, the first seal, and also within the icebox shale to see if there's any pressure differences. And of course, there shouldn't be any, but that will be detected on there. Along there also is our fiber lines for digital pressure and temperature all the way down, and also a digital acoustic line, as far as we could get it down on that particular well. Did a lot of coring on that as well, and a logging program, and I'll talk a bit more about that in a minute. Now here's the deepest well. Beat the past one by 4 meters. This is the observation well, and what it's meant to do is to allow us to take more readings, because it's not an operating well. It's kind of sitting there, and one of the key things we want to do within the Aquistore program is to inject CO2 into the injection well and then find it at the observation well and mark the times and everything else, injection rates. What that allows us to do is to confirm the models that are run that are predicting where the CO2 is going. With all of the studies on storage underground, the main thing is public assurance, regulatory assurance, and they want to know, okay, is reality the same as what you're predicting? So we have prediction models that have been made, and once we start injecting CO2, we can then start confirming, does it go that far, where does it reach? We're analyzing pressure pulses prior to the CO2 hitting the observation well. So a lot of work has been done, and we're just awaiting some of those things. Interestingly, on that observation well, we're calling it the smartest well in Canada. It just has a ton of jewelry on it. A lot of it casing conveyed instrumentation on fiber lines, and it's got way more measurement than anybody would ever do for an operating commercial situation. But that's not the point of Aquistore. Aquistore is to validate, it's to make comparisons, it's to find out what works best in these situations. What is overkill? What is the minimum sets that we need in order to get the data, in order to have that public assurance that what is happening underground is what was predicted. We also have a fluid recovery system, and on the well cross section, you would see it down there. And so we can take in situ operating fluid samples. It's on the outside. It punctures through there. This was all developed and machined at the University of Alberta, and went down hole in there, and it survived everything, and it's looking good. It has a couple of stainless steel tubes that run all the way up the casing to surface, allowing easy sampling of the fluid right at surface in our test facility that is currently having a building put over top of it. The core program, we did coring obviously in our target zone. We wanted to find out what was there, look at our areas of perm, make sure our perfs and everything else can go into the right area. We also did a core in the Bakken. A lot of interest in the Bakken in Saskatchewan and North Dakota. We took that core. It was basically encapsulated in wax immediately after coming out of the core barrel. What we wanted to do there was preserve the in situ condition as long as possible. We wanted to look at that upper shale to determine its geomechanics, because one of the things is, are you going to fracture things? And of course, although we're not in the Bakken in this particular case, we still wanted to know that in case we are going to go in the Bakken. So a lot of work was done on that, and a variety of agencies, the University of Saskatchewan, EERC, are doing work on our cores in terms of the actual Bakken piece and also that upper shale. Also, as you can see in the note here, there was a special side core tooling device that was used, and we have about 30 different cores along the side of the well, looking at a variety of things: lithology, X-ray. A lot of work has been done on characterizing the formations, and that work is necessary if you're going to be doing your predictive models. You need to really know what your porosities and perms are for that area. And again, learning from Weyburn and Mydale, we decided that let's take some gas samples all the way down, and let's run some fingerprints, I call it. Let's do the DNA on the gas samples. Let's look at the isotopes. So we were able to collect roughly 70 different gas samples, simply coming up through the mud, through the Pason detector. You can see the picture here of the collection device, and then that sample would be taken away and actually gone through all the isotopes and all the chemistry and all the data that you can get off that. We found out in the Weyburn that's very important that you make a data set of what's there naturally. So if someone comes and asks you, well, we think there's a leak, you can kind of go just like they do on CSI. You can have a check, and if things don't line up, then that's not where it came from. Because what we're doing is MMV, I'm going to spend some time here showing you just the extent of what we're doing here. And again, I preface this by noting that this monitoring is, I don't want to say excessive, it's just very extensive. And our goal within the Aquistore project is to determine which technologies are the most effective and efficient and cost-effective. So you can see in this diagram, the power plant is on the right-hand side, kind of where the discoloration is there. That's just from the satellite shot. That's nothing to do with the power plant, right, guys? And you can see where the the injection well and the observation well are, just about 1.5 miles away from the plant. This is the area of interest for us. Within that area of interest, we put a permanent seismic array of, I believe it's 630 geophones, and you see them in their blue dots there. That's approximately 12 square kilometers. We wanted to use permanent because that would allow us to have the best method of actually duplicating and replicating the data, because those aren't moving. It's not as if you have to relay the shot program and the phone's on the surface every time. They're not moving, so they're there, and we should be able to have excellent repeatability on the seismic. And there's a picture of, again, you can see it was done in wintertime. Despite the fact that Saskatchewan has 2 seasons, winter and construction, the odd time we have to do all of them in one. The geophones are put down about 20 meters, as I said. In the green dots there, I hope you can see those. Those are where we did soil gas probes. And I think there's about 50 of those that are there. And you can see it right there. There's 2 types of soil gas probes that were used. You can see in the lower right-hand corner, there's one that is actually in the earth, and you can see another form of doing soil gas sampling with a device that sits over top and sucks in from there. In the blue, those are what we call monitoring superstations. They have GPS and INSAR attached to them. That's kind of what they look like there. And again, we've been collecting baseline data from that for some time now. And I believe one of those things detected the earthquake off of Vancouver not that long ago. The red here, that is the locations where we had the vibra-sized trucks out to do the 3D seismic over that area. Just for interest's sake, you'll notice there's some areas that are absent within that grid that we wanted to do it in. Those were areas that were just too wet when we went out there, and the wet spring prevented us from doing a complete 3D over that area. One of the new things that we're doing is the fiber recording with the digital acoustic line. Basically, again, as I said, with Aquistore, we're trying to evaluate a variety of instruments. The goal, as I said, is to determine the ones that are the most efficient and effective. And as we move forward with projects in CO2 storage, installing an array of geophones downhole just is probably not a reasonable solution. They're big, you'd have to have larger holes. They don't withstand some of the pressures and temperatures that might be downhole, especially if you're going very, very deep, if you're offshore in particular. But over the last number of years, fiber optics have come to the forefront with respect to some downhole, in situ, casing conveyed monitoring. And these are simply strapped to the side of the casing as it's being lowered. And if you can appreciate that, just think of the rig lowering the casing, and every 7 to 10 meters, they got to strap the casing and the tubes all the way down, 3.4 kilometers. Probably takes a long time for them to do that. Certainly a lot longer than just running everything in. So what we're going to get out of this is the impact and the accuracy that we can compare to the digital line to geophones that we have. Now, the digital line is not as direct as a geophone. It can handle different geometries. It's only picking up something on there, but it's totally repeatable. It's every meter of there, so you can get a great vertical seismic profile. And I would think in this business, where we're looking at fractures being a cause of leakage within the geological formation, looking at vertical fractures would be something to be very, very important. So we're looking at this and doing vertical seismic profiles, and kind of outside of the CO2 industry, if I could say, the results from this are quite outstanding. The accuracy and what people are able to do with these digital lines are quite amazing, and we're getting people who want to look more at that. This is the kind of image that it puts down for a vertical seismic profile, and I have to tell you, I don't understand any of that. I'm not a geophysicist, but to those people, that's like Shakespeare. Communications. Again, in the symposium, we've heard a lot about communications. We've heard a lot about going out there. It's been talked to in detail. And what I want to say about that is that PTRC, with its partners, whether it be Synovus at Weyburn Mydale, or whether it be SaskPower for the Aquistore project, we've learned a lot. We've worked together with them, done a lot of outreach, And I guess one of the culminations of that is the book in your kit. It's a book that was written by Norm at PTRC, and he's actually going to be presenting that at the GHGT conference in Austin next week. So that's just part of the stuff that we have learned with that, and our experience is you need to work with your partners, you need to work with the community, and don't forget the international view of things as well. Because although we sit here and we sometimes look at our own communications and outreach locally, and we think that's it, you need to examine what's going on in that international sphere as well. Especially if you're doing an early stage project. Because people are always, there's not everybody out there who's singing from the same hymn book, and they may have issues that they want to discuss with certain media. The good news is that the capture unit is capturing it, the compressor has got it compressed, it's in the pipeline, it's heading to the off-taker, and what's left now for Aquistore is to get its program put in place with respect to the dates, the timing, the volumes, repeat some of our testing, keep measuring the pressure and temperature as things happen down in that injection well, and we're going to have data here for 3 years that is going to, I don't know how many terabytes of data we're going to get in some of this stuff. It is going to be massive. It's going to add to the data program that we have already from the Weyburn-Mydale project. After the initial injection, again, continuing to monitor. 3D seismic survey, let's do that again. Let's continue to monitor our vertical seismic profiles. Let's use the DAS lines and all that. Again, go to the surface. Are we seeing anything? What's there? And all those other issues. And one thing I want to mention about the seismic survey and the DAS lines and all that stuff. We heard in the conference so far about induced seismicity. That seems to be the latest thing that people want to bring to the table as an objection. So what we have on that is we have a program where we have 6 new seismometers. 3 of them are actually part of the Aquistore program, and another 3 are part of the Sask CO2 user program. And one of the projects there is to look at the results from the seismometers, as well as all the other activity we're doing on our permanent array, and compare that to what we know as activity in that area. Now, that particular area not only has the power plant, it has EOR project at Weyburn-Mydale, which is 50 miles away, easily detectable in some of those. It has fracking going on. We all know that's the next dirty word after seismicity is fracking, because they cause the same thing. And it also has mining, potash mining. So the task, and we have a project for that right now, which is funded in part by the province of Saskatchewan and also the US DOE, so thank you for that, is to look at all these man-made activities and try and correlate that to what's being recorded by the various seismic tools. And the neat thing is we're going to have 3 different seismic tools out there. So we should get the best data set of anyone that we can think of on induced seismicity from anything we're doing within Aquistore, anything that's going on in the oil patch with respect to water flooding and or fracking. We'll be able to get the magnitudes and then also correlate that with what might be going on in the potash situation. So a lot of work to do on post-injection. We're looking forward to all those things. And I would just want to conclude by acknowledging all those professionals, the people at PTRC, those of our contractors. There's a number in the room. Obviously, the SaskPower people that have helped us with this as well. I want to thank them all for their contributions to the projects over the various years. And I would entertain any questions that can be directed to Kyle. So, thank you.
Thank you, Ken. We have a little bit of time for questions. Kelly?
Quick question. Ken, what might be of interest is a situation where say the EOR off-taker temporarily doesn't take stuff. So in that event, the plant is running. Is there capacity, for example, in Aquistore, to take up the excess? And then after, if the EOR operator needs stuff again, to resupply the CO2? Kind of helps the plant in terms of its load carrying capacity.
Right, great question, Kelly. And that is part of the learnings we're going to get from Aquistore, because it is installed in a real, live, operating power plant and an operating oil field. So the injection well itself, keep in mind that it was always constructed as one well, and one well has its limitations, and those limitations are its injectivity will be less than the full amount that SaskPower can produce. So the assumption there was there'd be always CO2 going to the off-taker for CO2 for EOR, and we'd be there for the residual and or for times when there's plant shutdowns. So those operating things will all be worked out, and we can understand the hysteresis within the field itself and understand how the molecules go in and out down that formation. So it's going to be a great learning data set, and as I said in my outside, this is a journey we're on. We're not finished, and it's just going to be more and more as we progress.
Quick question for you, Andrew Kavanagh, Statoil.
Other questions?
Yeah, is this mic on?
Sorry. Oh, my apologies. Yep.
I was just wondering, you talked about an injection phase and a post-injection phase. Do you know how long the injection phase will be for, and how much CO2 is planned for that phase? Right.
Yeah, good. Another great question. Thank you. The work that has been done with the modeling, and again, what we want to try and do is start the injection phase until we get breakthrough in the observation well. That modeling suggests somewhere around 20 to 30 days based on 1,000 tons per day. So look at that as a month, and that would be 30,000 tons. That is what we want to start with. After that, will be part of the operations within the SaskPower commercial arrangements that they have. But that is what was referred to as that initial phase.
Ken, can I clarify how much you're going to be injecting over the 3 years?
Well, a lot of that depends upon the operations within SaskPower.
Yeah, sure.
We'll have the ability to I see no reason why that formation could not take 1,000 a day for every day. But it all depends upon the SaskPower arrangements that they have. And keep in mind that the economic model depends upon the sale of CO2. We've heard that a lot today. There's no economics in pure storage. So the amount of pure storage, we want to do our demonstration in scientific research, absolutely. And after that, it gets into the real operations of SaskPower.
So then to just further clarify that, if you can sell all of the CO2, that doesn't leave too much for Aquistore. So how are you going to handle that?
Well, Mike and I talk about this all the time. And everyone here in this room is on the same page with respect to the integrity of the science experiment, the integrity of the demonstration, because to do it without having the proper learnings would simply not be in the cards. So we are going to work together, all three parties, to do our very best in getting the highest quality research program that we can on this.
Any more questions? Well, if not, I'd just observe that Saskatchewan's been fantastic for turning up real pioneering projects and pioneers. I mean, the Weyburn Mydale project was fantastic, and the pioneer there, the person whose enthusiasm was above and beyond the call, and it becomes an obsession, which is what you need to get these things through, was Malcolm Wilson in the first instance, and then of course we've got Mike with the same enthusiasm / obsession that is absolutely essential to carry these things through. I think here we've got the makings of a third project that is going to be of global significance. I really think that it has the potential to be a very, very important project. So thank you for putting it together. I think we're all grateful for that, and ask you to join with me in thanking Ken for his presentation.